Welcome to Spring LIB.
All right, so we are starting with E3-methyl 3-hexene. Okay, so that's a transalkene. Let's call this carbon 3. So we've got a 3, 4, 5, 6. This would be carbon 2, and then carbon 1. And then we know there's also a methyl on carbon 3. Right, 1, 2, 3, 4, 5, 6 carbon chain, methyl on 3, and it's E because the two ethyl groups, or the two largest chains, are opposite to each other across the double bond. And we're reacting it with Br2 and methanol. And recall that when you react bromine gas and any sort of alcohol with an alkene, what you end up with is the anti-addition of bromine and like a methoxide, OCH3 or OMe, right? So they should be added to opposite faces of the molecule. And it's sort of arbitrary which side they get added to, so we might get a molecule such as this. We might also get a molecule, or we would get an equal proportion, this molecule where bromine added to the back and then our methoxide added to the front. There is one note of preference, and that is that if one side of the double bond is more substituted than the other, we end up with the bromine on the less substituted side and the methoxide on the more substituted side. So in the case of our molecule here, since carbon 3 is more substituted than carbon 4, right, we should expect that bromine will be on carbon 4. This is where our bromine is going to go, and our methoxide is going to go on carbon 3. Okay, so what are the possible products we could get out of this? Give ourselves some space here. I'll also sort of redraw this so it matches. Right, they've drawn it like 1, 2, 3, 4, 5, 6. Right, they've drawn it like that. Okay. Scroll down a minute. Erase some more. Okay, so the possibilities, we know bromine is always going to end up on carbon 4, and the methoxide is always going to end up on carbon 3, which tells us, right, that answers 3 and 4 are not possible answers, right? That is, we know that the bromine has to go on carbon 4 and the methoxide on carbon 3, and carbon molecules 3 and 4 show the methoxide. For example, 3 looks like this. Shows the methoxide on carbon 4 and the bromine on carbon 3. Okay. There's another issue with it, and that's they're both on the same face of the molecule. 4 doesn't have the issue with them being on the same face. Sorry, this is OCH3, not OH. Nevertheless, because of the fact that it's a anti-addition, not a syn addition, 4 is still not good because we see the methoxide has been added to carbon 4. Okay, so then we've got 1. Here we see bromine on carbon 4, where it should be, and we see our methoxide on carbon 3, where it should be. But the problem here is that the methoxide and the bromine have been added to the same face of the molecule, so 1 is also no good, which leaves option 2, and in fact, option 2 is correct. Bromine is on carbon 4, where it should be, the less substituted carbon. And methoxide is on carbon 3. I drew that incorrectly. OCH3 is on carbon 3 where it should be. And we'll notice that they're anti to each other. That's bromine is on a wedge and OCH3 is on a hash. And then we'll also get an enantiomer version of this where it's the exact same thing, but bromine is on a hash and the OCH3 would be on a wedge.